Double integrals in mass. Suppose we have a region here. It could be a rectangular region, it could be anything, but now all we know how to integrate is rectangular regions. dA is dy dx, and rho is going to be density, which in this case would be kilograms per square meter. We're dealing with a two-dimensional figure, so this is a mass per unit area. So the dm is going to be a small little piece of mass. There's going to be density times area, kilograms per square meter. Times square meter, it gives you kilograms. That's dimensionally how this works out. So this is what we're going to integrate. We're going to set up an integral, just integrating this instead of dy dx, and we will get a unit of mass. So in this case, suppose we have a thin plate with a density xy. It would, the density varies jointly with both dimensions, both axes. The further we get out, the more dense it's going to be. Right here, 1, 1, the density is 1 kilogram per square meter. So if you take this little square, it would have a mass of about if you were to take this whole unit square, it would have a mass of roughly 1 kilogram. Out here at 3, 4, if you take a unit square, it would have a mass approximately of 12 kilograms. Much more massive. Kilograms, 2.2 pounds, so 12 times 2.2 would give you the weight of it on Earth in any event. Of course, this density varies continuously, so at any point, or at any area, any finite area, there's going to be some variation. Well, all we have to do is integrate x, y, dy, dx. As density, x goes from 1 to 4, y goes from 1 to 3. So now we're going to integrate. We integrate, first of all, inside. We treat x as a constant, and the reason is we're integrating upward, x is constant. For a given x value, y varies. So constant integral of y dy is y squared over 2. Keep x constant. Integral from 1 to 4. Xy squared over 2, and that is from 1 to 3 dx. Substitute 3, substitute 1. We get integral from 1 to 4. X times 3 squared over 2 is 9 halves minus 1 half dx. And this gives us integral from 1 to 4. That's 8 halves, which is 4. You can put the 4 out front if you wish. And we get 4 times x squared over 2 from 1 to 4. And we get 4. 4 over 2 is really just 2. And then you can plug in 4, plug in 1. 16 minus 1. 4 squared 16, 1 squared is 1. And that's 30 kilograms. And that would be exact. Here we said like a 1 unit square would have a mass of 1. Over here it would have a mass of 12. And of course, in between it varies. That's the exact mass, 30 kilograms, using calculus, taking into account this continuous function. Okay, that's all for mass. We need to do average value of a function, and then also we're going to do volume. But the applications are pretty simple in this section. They're all over rectangular regions. So.